All right. Okay. So as I was going through the notes for this stuff, because I do everything ahead of time. So I got through and I looked at this and I was like, this is so stupid easy that I just don't want to do it. So what we're going to do is we're going to burn through these notes about chords and arcs. We're going to go super fast and move on to the next day. So these are so easy. So we're going to talk through a few quickly here. So you're taking notes, not on your screens. Thank you very much. All right. So congruent chords and arcs. Sounds just like it says. Two chords are congruent if and only if their corresponding arcs are congruent. So I'm going to highlight a couple of chords here. What are some chords in this circle they've got? Two chords. Where are two chords in my circle? A, B, good, and C, D. There's our two chords. And so these two chords will be congruent if their corresponding arcs that they intercept. So those arc AB and arc CD, if those arcs are congruent, does it make sense to you that the chords that cut them off are also congruent? Yeah. Makes total sense, right? Okay, so then AB is equal to CD if the measure of arc AB is equal to the measure of arc CD. So if the arcs are congruent, then the chords are congruent. If the chords are congruent, then the arcs are congruent. Super easy. Also, two chords are congruent if they are equidistant. If they are equidistant from the center of the circle. So if they are equidistant from the center. To be equidistant from the center, we're going from the center directly to the chord. And to measure distance, we always are perpendicular, straight to it, all right? Perpendicular. So this is the distance to the chord, that little EF segment there. And you can see that it's perpendicular. And if those two little, I'm going to call them pieces of radii, if those are congruent, then the chords are also congruent. So once again, AB is equal to CD. So the chords are congruent if those little baby radii, FE, is equal to EG. If the radii are congruent, then those chords are also congruent. Does that make sense to you? If they're the same distance away from the center, isn't that chord the same size as if you go the other way? The same distance, you're going to get the same size chord, okay? So, lots of things that make congruence here. We also want to know that if a diameter or a radius is perpendicular, so you can see we have perpendicular here, so I got a little radius, the radius is EI, and it's perpendicular to a chord. So if I have something perpendicular to a chord, then, this is real interesting, it bisects the chord and its arc. So when we look at this little radius right here, EI, it's perpendicular to the chord. Can you see that it even looks like it gets cut into two equal parts? Does it kind of look bisected to you? And then if that chord is bisected, does it make sense that the arc would also be bisected as well? Okay, so if you have something that is perpendicular to the chord, that chord gets bisected, so does the arc. Okay, so kind of nice, lots of things going on here. but it's super easy. So let's just run through really fast, setting up a couple here. On number 1, I see that I have marked, what's marked congruent? 2 chords, so I have congruent chords. And if I have congruent chords, what does that mean? Congruent arcs, yes. So what's our equation? Yeah, they're equal to each other. So 115 equals 7x plus 24. And I know you know how to solve for x, okay? Let's look at number 3. So we're just going to burn through. See how you do this? What's marked congruent in our picture? Congruent arcs. So we have congruent arcs. And if we have congruent arcs, what does that mean?
Congruent chords.
Then we'd have congruent chords. Very good. So congruent chords. Very easy. So what's our equation if I have...
Minus 34 equals 4x plus 1.
9x minus 34 equals 4x plus 1. Beautiful. And again, I know you know how to solve for it. Okay. Easy peasy.
Thanks, guys.
All right. Let's look at number 5. 5 is a little more challenging. Am I burning rubber here? Am I going too fast? No. You guys are like, let's just get this done. Okay. What's marked congruent in our picture here? Hi.
Chords.
All right, we got congruent chords. All right. We're going to move on to the next thing, so it's not like, yeah. All right, so we have congruent chords, which means we have congruent arcs. All right, so if one arc is 6x minus 20, what's this other arc? 6x minus 20 as well. So we have congruent arcs, but how do we set this one up?
So you do minus 6x minus 20 plus 6x minus 20 plus 76 equals 360.
All right.
Right there, Nick.
All right. So yeah, we have the whole entire 360 degrees here is all the arcs added up. So 76 plus, can I do twice 6x minus 20? Because then I don't have to write as much. Yeah? Okay. Fantastic. Here, let's look at number 6, and then we're going to turn the page. Let's look at our picture. What is congruent in our picture here?
The arc.
All right, so we have congruent arcs, and if we have congruent arcs, what does that mean?
Congruent chords.
Congruent chords. So my chords here are congruent. So we have congruent chords. Now, if the chords are congruent, what else must be congruent? The little baby radii, yeah, these guys right here from the center, I don't know what to call them. They don't have a, actually they do have a name, but, well, no, I don't know that they technically do. These little dudes, PN and MP, little baby radii, are congruent. So I'm just going to say congruent little radii.
Call them Billies.
Billies. Okay, which means MP is equal to PN. They are the same distance away from the center. So that little distance from the center to the chord, those are equal to each other. All right, questions on this stuff, or is this like silly easy, eh? Silly easy. Okay, and that's what I thought. I was like, I do not want to spend time doing that. So turn the page and let's talk about inscribed angles. All right, so this is section 10.4, and you guys have a Delta Math tonight. I did update your grades. I will update them after school real fast, too. So if you're missing, like, you have time today to do today's Delta Math and yesterday's if you haven't gotten it done, okay? All right, so today we're talking about inscribed angles. An inscribed angle. An inscribed angle is an angle with its vertex on the circle with two sides that are chords. So in my picture here, here's my vertex of my angle on the circle, and I have chord AB and chord BC.
Please excuse the interruption. At this time, please release the varsity baseball and softball teams. Thank you.
Hey, wait, before you leave, write this down. Really fast. This is so easy. If the measure of this arc is 100 degrees, what do you guess that this angle is?
100.
It's not 100.
80 something. It's 80.
No.
60.
60?
No.
200.
Less.
40.
More.
180. 180.
50!
Yes, sir. Ready?
What's the relationship between the arc and an inscribed? Okay, good, you can go. Okay. All right. Okay. So if you get that in, then it's pretty easy. Good luck, guys. All right, here we go. So here I have my inscribed angle, and today the basic rule here is that if you know you have your arc measure, this is called the intercepted arc, and so that's the second bullet. The intercepted arc is the arc that lies between the end points of an inscribed angle. So it's really between any kind of angle. It's an intercepted arc. But so this is the intercepted arc, and it's 100 degrees. And it turns out that the measure of the inscribed angle is equal to half the measure of its intercepted arc. I like writing it in the picture because it's a really quick way to tell the relationship, right? So the measure of angle ABC is half the measure of arc AC, which I don't find all that helpful. What if I know the angle measure? So I know the angle measure is 50 degrees. What do I have to do to get to the measure of the arc? Double it, yeah. So all I have to do is twice the angle is equal to our arc measure if we have an inscribed angle. But I don't want you to be confused with what we did the day before. A couple days ago, I don't even remember the day now, we had this type of angle. What is this angle? Yeah, that is called a central angle. And so angle APC is a central angle. What's the measure of the central angle? 100. It's the same as the arc. Okay. Look at me, Curtis. All right. So central angles go through the center of the circle. They are the same measure as their intercepted arc. But an inscribed angle goes all the way across, and you can kind of see how this angle is much wider than the green angle, okay? So it even looks like it's half the size, okay? All right. So let's look at a diameter here. Diameters are always, that's okay. Diameters are always half, yep, thanks. We got a diameter, so always a good idea to look for diameters. Now, if I have a diameter, what's the measure of the semicircle? 180 degrees, very good. So now we know that that blue arc has a measure of 180 degrees, and I have an inscribed angle. Angle BAC is an inscribed angle. All 3 points are on the circle. So what's the measure of
90.
that inscribed angle? 90. How'd you get 90?
Because it's like the point, it's like half 180.
Half of 180, absolutely. It's 90 degrees. So, if an inscribed angle intercepts a diameter, then it is a right angle.
You're so right.
So the measured angle BAC is 90 degrees. So paying attention to diameter is very, very useful. Now, overlapping arcs. Got to be a little bit careful here. We have, if I have this arc measure, let's say that arc measure, oh, dang it, I did it wrong. Let's look at, not that blue one. Let's look at arc, sorry, my bad. Let's look at this arc AD there. Let's say arc AD is 60 degrees. So this arc AD is 60 degrees. I want to know the measure of angle ABD. What's the measure of angle ABD? 30. Again, this is an inscribed angle because all three vertices are on the circle, so that's a 30-degree angle. All right. What's the measure of ACD? Also 30. And that's easy to arrive at, right? You can see the relationship between the arc and the angle. All right. If two inscribed angles intercept the same arc, then the angles are congruent. Okay. The measure of angle ABD is equal to the measure of angle ACD. Two angles are equal to each other. I much prefer using numbers. All right, a little bit of practice. All right, and number one, our arc is 62. What's the measure of our inscribed angle? What'd you get? Which is 62 divided by 2. We get 31 degrees. Excellent. Okay. Here, we want the measure of the major arc, DGF. DGF. What's the measure of that arc? How'd you get 226? 113 times 2, 226. Very good. All right, what do you see in number 3? Yeah, good. We've got a diameter, and that means that we have a semicircle. How many degrees does a semicircle have? 90, yeah. So again, this intercepted arc then is half of 180, or 90 degrees. All right, is this easy or hard? Pretty easy. All right, this one is a little tricky. We want arc BC right here is what we're looking for. What do you got to do? Okay, it's true. We do have a diameter. What about the pink arc? Can we figure out the pink arc?
Yeah.
Oh, yeah. All right. What do we got?
So then
Almost. 94. Very good. Okay. So, oh, okay. So, how did we get 94 times by 2? So, twice 47 gives us 94 degrees for the pink arc. And then, so how do we get the blue arc then?
180 minus 94.
Okay. So the diameter was important, and that gives us 86 degrees for the blue arc. Fantastic. Okay. Here we are looking for the measure of angle JKL. What do we need to know? The whole, yeah, that whole, I need to know this blue arc. How do we figure out the blue arc? Well, yeah, drawing in a diameter won't usually help because you don't know where it, like, I could draw a diameter starting at J, passing through N, and ending on the other side, but I have no idea what that is. Okay. So, Terry, what did you say? Add 53 and 65 and do what with that?
Subtract it from 180.
How, you're close. 360. Why 360?
Just the whole circle?
The whole circle is 360 degrees, so 360 minus 53 minus 65 is 242 degrees. So this arc is 242 degrees. So how do we figure out this angle measure then? Divide it by 2. So that gives me 121. All right. Okay. Let's see. I'm trying to find the measure of angle RST. RST is right here. All right, that's the first one I'm trying to find. What would be helpful to know?
The radius of arc.
So you would,
You want to find the
arc.
arc of arc.
So you
Arc.
360 minus
Yeah.
39 minus 64 minus 75.
Okay, so we got all the other degree measures. So 360 minus 64 minus 139 minus 75 gives me 82. So this arc is 82 degrees. And so if I know the blue arc is 82, what's my little angle? 41.
That's the same as the other one.
Yeah, and RUT is also 41. All right, let's turn the page. Oh, sorry, let me stay there a second. Anyone have any questions on this page? Okay. Turn the page, you're just going to do 9 and 13, and then we'll be done. And by do, I mean set up. No. Okay. All right, let's look at number 9. What do you notice in number 9?
So why don't you just do 26x?
Hold your roll, hold your roll.
Equals 13x minus 1.
How'd you get 90?
Because it's intersects the diameter, so it equals 9.
Yeah, we got diameter here, which means my arc on the other side is how many degrees? 180. And so my angle is going to be right in 90 degrees. Half of that 180 is 90. So we have 13x minus 1 equals a 90 degree angle, okay? All right, number 13. Angle FGH is 6x plus 21, and the measure of major arc FJH, so major arc is 17x minus 28. What's the relationship between the angle and the arc? Yes. Twice the angle is equal to the arc measure, and so that is exactly how we would set that up. Twice the angle equals the arc, if you were to think about it that way. All right, folks, that's it for me. You have Delta Math. Use your time wisely. A lot of people got a lot done last hour.